Good morning. This is your stats sensei, Mr. Spensei, and we're looking at 2018 question number 3. Approximately 3.5% of all children born in a certain region are from multiple births, that is twins, triplets, etc. Of the children born in the region who are from multiple births, 22% are left-handed. Of the children born in the region who are from single births, 11% are left-handed. What's the probability that a randomly selected child born in the region is left-handed? Okay, so you can already see from that I used a table. Why did I use a table? Because I have two variables, multiple births and what handed you are. So really important to determine which number of the numbers is associated with one variable. So these are my numbers, and let's look at them all. Approximately 3.5% of all children born in a certain region are from multiple births. That has nothing to do with being left-handed or right-handed. That is associated with one variable. It's not conditioned on anything. That looks pretty good. Let's look at the others. Of the children born in the region from multiple births, from the group of multiple births, 22% are left-handed. Multiple births and left-handed. That's two variables, and we're looking for one. Of the children born in the region who are born from single births, 11% are left-handed. Again, we're talking about births and what hand, that's two variables. So the number we want is 3.5 or 3.5. So that's 0.035%. That's going right here. Always put that one right here. The single number goes here. And then one minus that gives us 0.965, and this gives us 1. We're going to bring those numbers up. So 0.035, 0.035 in small, 0.96, 0.965 in small, write that down. And then we need to go back. And it says, of the children born in the region from multiple births. So now we're looking at the multiple births column. 22% are left-handed. That's 0.22 are left-handed. All right, so 1 minus 0.22 are right-handed. Then we go to other children born from single births, in other words, not multiple, but singles. 11% are left-handed, so 0.11, and 1 minus that gives me 0.99. At that point, I multiply all this out, and I get these values. And I'm speeding through the multiplication. Please know this plus this equals this plus this equals that. What is the probability a randomly selected child born in the region is left-handed? So I'm looking for left-handed. That's 0.11385. All right. Now, to get full credit on this, you had to come up with the appropriate number and show work. Well, so here's the 0.11385. This is my work shown, which means I need these little numbers shown to be multiplied. All right, really important to do that. Otherwise, you're not going to get full credit when you actually went through and did a pretty challenging problem. The next thing, what's the probability a randomly selected child born in the region, that a randomly selected child born in the region is a child from a multiple birth, given the child is left-handed? So given that they're left, and remember, it's always intersection over given. That's what we're working with, intersection over given. Well, we're given left-handed, and we have intersection on top. So multiple births. So there's our intersection over given, and 0.077 over 0.11385. If you have one of these numbers correct and in the right place, you got partially correct. If you have both numbers, and of course you have to have the work shown. You have to say where the 0.077 came from, and you have to say where the 0.11385 came from. Assuming you have that, you're going to receive full credit. Okay, so a random sample of 20 children born in the region will be selected. What's the probability that the sample will have at least 3 who are left-handed? First off, we have a fixed number of trials. As soon as we have a fixed number of trials, I'm thinking it's a binomial. So binomial trials. We know the probability that are left-handed because we calculated it up here. If you have whatever value you used up here, whatever value you have right here, you need to make sure you're using it right there. And we want the probability that X is greater than or equal to 3. So I made my little number line, and I'm interested in this highlighted portion. So for my work shown, I went 20, choose 3. There's my probability. And 20 minus 3 is 17. And notice it's 1 minus the probability. Plus, dot, 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 plus. So that was the first one, 20, choose 3. Then I need 20, choose 20, 20, choose 20. 0.11385 to the 20th power. 1 minus that, and then 20 minus 20 is 0. On the calculator, I get 0.4021, and I'll show you that in just a moment. All right. So the calculator would look like this. 1 minus the binomial CDF of trials is 20, P is 0.11385, X equals 2. So let's go about doing that. 1 minus second vars, binomial CDF, trials is 20, P is 0.11385, X is 2. And I end up getting 0.4021. Alternative way to have shown work would have been 1 minus 20, choose 1 minus brackets 20, choose 0, because we subtract, and then 0.11385 to the 0, because we didn't want 0. We also didn't want 1, and we also didn't want 2. Make sure that you subtract out the highest number you don't want. Never subtract out the things that you do want. All right. So part C. Had to use a calculation based on the binomial who were left-handed. We needed to specify our trials and our probability. Notice if you have, I would recommend doing this, but if you didn't, if you just had this and you had this, you've expected your trials and your probability. All right. And then we have to calculate the probability for at least 3. So we need to show that we're using 3. 20 choose 3 to that would show it, or this would show it. And then we had to get the correct response. All right. That's the way you get all the points. And if you, to get a partial, if component 1, in other words, you showed a binomial, and 2 or 3 of the other 4 components, but you have to show it's a binomial either by formula or by writing it down. Okay, I hope that helps, and look forward to seeing you on the next one. Thank you.